So we also studied about types of frictions. We have static friction and kinetic friction. Static friction is the friction which is produced in an object when one object is allowed to slide on another, but the object is stationary, it doesn't move. Frictional force that tends to prevent a stationary object from starting to move is called static friction. It is represented by Fs, in subscript is S. And kinetic friction, when one body is allowed to slide on another, if the body is moving, then the friction is kinetic friction. It is represented by Fk. Here is a rule that Fk is always less than Fs. Static friction is always greater than kinetic friction. Actually, friction is opposing force, but if an object is still stationary, this is static friction, and if object is moving, this is kinetic friction. Now we will see that friction depends upon two things I already discussed in a class. Firstly, it depends on the area of contact between two objects, providing the surface of the hard or non-deformable surface are hards. For example, if we have two objects, this is table top, and this block is allowed to slide with the help of pulley, if this is a pulley, and this is thread, and you applied force here. The weight of the object will be directed downward, and normal reactional force is acted in upward direction. The point of contact between these two objects is here. Microscopically, one object is like this, the other object is like this, so this is the point of contact. It depends upon surface area, that how much area is connected between these two objects. For example, if we replace this object, this is table top, and this is the same box but having wheels. So if you want to push or apply force here, you can see the difference between these two objects, which will slide easily, and where the friction force will create greater amount. You can see that the point of contact here is very less, and here point of contact is very high. So here the friction is more as compared to this one. So it depends upon area of contact or point of contact. The second thing is that its magnitude is proportional to the magnitude of the normal force. So here we can say that the frictional force, firstly, if we will say about static friction, the static friction Fs is directly proportional to the magnitude of normal force. Static friction is equals to mu s Fn. What is mu s? Mu s is coefficient of static friction. So we can say that here every friction having that coefficient, this coefficient is mu s, if this is coefficient of static friction, and mu s is equal to, because our formula was Fs is equals to mu s Fn. So if we will divide Fn here, then Fs divided by Fn. The unit of force, frictional force, is Newton, and the unit of applied force is Newton. They cancel out with each other, and it is the unitless quantity.